In the UK, there's a traditional pattern of pewter tankard with a glass base, supposedly so you could avoid taking the King's shilling and joining the army, though this is probably not true. These here are from the Union Bar from this university I attended as a student. Every Union post has a pot, and the names of the incumbents are engraved on them from the year dot. Some of these go back, the ones I have got 1923. This is one I can use. It's cracked around the base, it's cracked around the top, but if we look carefully, somewhere on it will be my name. And that means that any time I go to the Union Bar, I can drink out of this pot. The RCS publicity of the pot we saw just then is unusual amongst the ones I've been given to fix because the base is intact but falling off. This is a ski club pot, they're clearly heavily used, with a cracked base. Another one here, a 2-2 club pot with a cracked base and a bad dent which needs sorting out. You can see there the separate ring which holds the thing in. Another one, ICU pot of some sort, and here we have an underwater club pot, again with a cracked base, probably leaking water everywhere, which really probably upsets the underwater club. You could see on one of the dented pots that there's a ring holding the glass in which is soldered in place. I have had some success in desoldering with an induction heater. However, this proved difficult to control. It's hard to melt all the solder and not melt the pot. So in this case, this one here, you can see I've just machined out the ring. I'm going to put a new one in. So inside there's an inner rim, then a silicone seal, then the glass disc goes in, and then a soldered in pewter ring. This particular pot is the ladies' netball captain pot. I'm sure they'll be very grateful to get it back. To cast the new rings, I've made this 4-part cast iron mould. It needs to be in 4 pieces to come apart and release all the various risers, runners and the shape of the mould. It's been painted with red ochre and white spirit to stop the pewter sticking to it. If it looks a bit like red oxide primer, I don't think that's a coincidence. I think that's exactly what red oxide primer traditionally is. So this inner piece slides up through the middle and protrudes through. Then the outer parts clip onto that and retained by that inner ring, and that leaves a void which we'll fill with pewter. Then when that ring drops out, its pod is pushed out, it creates enough clearance to split at the riser and runner and release the cast pewter ring. So that in the future I can tell which pots I repaired when they break again. There's an engraved nub here saying CVIR, for Charles VI of France, who had a morbid fear that his glass bottom would break. This is the process I'm using for casting the rings. I've not got any special equipment, this is my kitchen hob. I have a stack of Swiss francs to keep the inner part of the mould from falling through when it's on here. Then I simply assemble the top rings with the pouring hole in a convenient location. Then I simply light the gas hob underneath the mould to warm it. I found it needs to be about 330 degrees, which is surprisingly hot for them, but otherwise the pewter doesn't completely fill the mould and I get cold shuts, etc. So that goes on for quite a long time before there's a lot of metal to warm up. Then I melt some other pewter, some fresh pewter, in this little ladle on the small ring, which it doesn't fit very well, but it works. I monitor the temperature with this infrared gun and a thermocouple. I don't really trust the infrared thing, it really doesn't seem to work at all well, it's very hard to aim, but the thermocouple part seems to work fairly well. I'm aiming for 300 degrees-ish on both parts, so there's quite a long way to go here yet. Once everything's up to temperature, I scrape off the dross with a teaspoon, because I'm really well equipped with foundry equipment. And then pour it in one fluid motion into the mould. Well, I say one fluid motion, that would be the ideal obviously. As it happens, I tend to miss. You can see because the mould is warm, the pewter stays liquid quite a long time. And just on the left you can see it's risen all the way up the riser. So that does mean the mould is completely full. The fact that the mould is preheated means that the pewter stays liquid for quite a long time, so I can scrape off the excess. Another piece of foundry equipment I could do with is some foundry gloves. Oven gloves are not really ideal for this job, not great for your manual dexterity. But here, by knocking the mould apart, everything sort of comes apart into pieces. And off camera, annoyingly, I can actually extract the ring that I've just cast. The machining work on this job is not really suitable for a CNC lathe. It needs a delicacy of touch, so I'm using my manual lathe. This is a Rivet 608, which is a rather pretty little lathe, but it's made of polished cast iron, so it would probably go rusty in the workshop. So to prevent that, and not at all because I've run out of space for any more lathes, I keep this in my living room. It's not great for the carpet. The next stage in preparing the retaining ring is to machine the OD to remove the sprues or gates or whatever they're called when you're pewter casting. The majority is snipped off and then the extreme OD is machined off with my Rivet lathe. The motor is a braked motor from a lift or crane, and that's what the rubbing noise is when it slows down and speeds up. The flat face needs facing off to provide a good seat for the silicone seal. I do this on the CNC lathe because it saves changing chucks basically, and this chuck can take soft jaws. I 3D printed these soft jaws specifically for this job. They're not as central or concentric as one might hope, but for this particular facing job that hardly matters at all. Much to my annoyance, the glass discs that I had cut by water jet at significant expense all came out oversize. The manufacturer did say they could only manage a tolerance of plus or minus 2mm, but they all came out exactly the same size at 1.5mm oversize, which means I'm having to grind them down with a diamond file. I'm doing this in my lathe. I don't like doing it because diamond glass dust isn't nice, so I've covered the ways, and I'll vacuum up carefully and do the best I can. Once the disc is approximately central, I then, with light tailstock pressure, with a rather rigid holding vice grip against the bed and my hand, try to push it into centre as well as I can, before finally tightening the tailstock some more, increasing the speed and grinding down to size. A problem with this is I get some edge stripping, but then all the ones I take out are the same. To hold the pots for machining, I made an expanding mandrel specifically for the job. There's an inner steel part with a cone at the end, some 3D printed wedges, and the whole thing is expanded by a second cone with a keyway, and then clamped down by a large nut. This allows me to machine the bases out. I was told by a pewterer that this couldn't possibly be done because the handle whirls around. I can only assume he had too small a lathe, because it's actually not a problem apart from one of balance. With the mandrel inside the pot, it's a good opportunity to sort out any dings, bends, and make things more circular and a bit more as they should be. I did attempt to straighten out the ding in the base at this point, but it wasn't very successful, and I had to go to the workshop and use a form tool and a bigger hammer. The pot is then set up in the 4-jaw chuck on the mandrel and made as true as possible, given the fact that it's not at all round, using a dial indicator and the normal 4-jaw chuck centering process. I actually, after this, took it back out again to sort out the ding in the rim some more to make it more circular, but I didn't video the second attempt to straighten it all up. The pot trued up and made a little more circular than in the previous clip. It was it's time to machine out the inner ring which holds the glass in place. After re-engaging the drive peg in the spindle, that is. It became evident at this point that this glass was held in with some kind of mastic or putty, which is another reason that the induction heater method wouldn't have worked. With the glass removed, which took some effort and a hammer, I was then able to clean up the sealing face where the silicone ring will go. It's critical that this has to be flat and smooth and true to the other machining. Thinking for the future, these pots will probably be around for another 100 years, it's important to only take off the minimum amount possible to make a clean surface for sealing to. I feel slightly guilty that I don't use the rivet more than I do. It's a very nice lathe to use, a joy to use in fact. Every adjustment is done purely with hand strength, no tools needed at all. The only spanner you need is the chuck key. The entire cross slide slides off to fit other accessories, grinders and millers and all sorts of things. There are pages and pages of expensive accessories. And even the tool height is adjustable. It's held in an eccentric, which I've done up rather too tightly here. But you can see that by rotating the outer eccentric and changing the tool angle, you can change both the tool height and the tool rake. I just set it back to the right height using the tailstock centre as a reference. Now we can start to machine the final outside OD of the ring to fit into the pot properly. Now to work at this diameter, I think I'm probably going to have to take the cross slide out slightly just to get a bit more reach. But again, this is just a finger lever. So this is one of the rings. It fits onto a spigot. It's held in place by a piece of machine plastic. I now need to machine down the OD of the retaining ring until it fits nicely in the 10-degree taper that I've machined in the bottom of the pot and clamps the glass tightly whilst making a good seal with the silicone seal ring. I'm doing this machining by feel, no measurements involved. It's hard to do tapers at the best of times, so I just have to iteratively until it goes all the way in. Clearly this isn't far enough in. Getting closer, just a bit more. The glass is actually loose, but the ring's nearly all the way in. And this will do. You can feel the elasticity of the silicone ring, and the glass is nicely clamped. I'm using some very low melting point 52% bismuth solder. This is the stuff they use for surface mount components. It comes in syringes. It's a 3D printed syringe squeezer which makes dispensing the solder somewhat easier. Sorry it's not better film, but I really was just doing the job at this point. I clamp the ring during soldering using a drill press and some tooling I made when I thought I was going to use an induction heater. So this is a tough knoll stroke Paxilin disc, which is heat resistant and non-conductive, and a carbon fibre tube. I'm using a hot air soldering device to attach the rings. I feel this gives me less risk of melting the pot itself than using a gas flame. I might eventually summon up the courage to use the gas flame, but for the time being the hot air soldering thing is working quite well. I took the pot away to cool it down because it was too hot and fill it with water, and marvellously it doesn't leak. One final machining operation on the rivet to blend together the old and the new pewter, and the job is done. And that's the pot finished and ready to drink from. But I have to wait until my own is fixed before I can, because you can't drink out of somebody else's pot.